All right, so I got your requests. Thanks for voting. That was great. I appreciate the fact that you guys voted on all the problems, how many problems you got done, and I appreciate the feedback on which ones you guys need. Now, I went through the book and I saw some general trends with the questions that you had. So with the questions that you had, a lot of things that were coming up I think are algebra things. So what I'm going to do first, before I do anything else, is I'm going to go through a couple of those algebra points. All right, so things that I want you to keep in mind. I'm going through the algebra, but it really does not differ with the trig, because we can do the algebra with trigonometry. Okay, just like we did the other day, tricks of the trig. Okay, same thing here. Okay, so a to the 1/2 power. If we go back and we try to remember what a to the 1/2 power means, okay, we know that something like a squared means a times a. It's telling us the power. Well, all of a sudden it becomes this fractional power. You need to remember that that bottom, the denominator of the power, really tells us a root. Okay, and the top really is still telling us the power. So the numerator tells us the power, and the denominator of that exponent tells us the root number. So this is really saying a to the 1st power, and then we take the square root of it, because that's, 2, square root base 2. So this a to the 1/2 power is really the square root of a. Now, that's a little bit big on my little check mark there, but that is the square root of a. Okay. Now, similarly, that means that things like a to the 3/2, okay, is something like the square root, because that's the denominator of the power. It's telling us the square root, and this is going to be of a cubed, because again, remember that numerator is 3. Okay, so that's telling us the power, and the denominator is 2. And that's telling us the root. Okay, so a to the 3/2 is a to the 3rd square root of all that. Now, another thing that seems to be coming up, I think some of us are forgetting our exponent rules. Okay, so let's take a look really quick. This is a separate problem. A squared times a cubed. Now, I know, because I remember my exponent rules, and I've kind of memorized and internalized this procedure, that a squared times a cubed is a to the 5th, because if I'm multiplying exponentials that have the same base, I get to add their exponents. Okay? Now, I'm not a big fan of memorization, or at least not memorizing without understanding why. So here's the reason why. If we look at this, a squared means a times a. And a cubed means a times a times a. Now, if I look at this, I realize I have a big long string of a's, and they're all essentially just multiplied. A times a times a times, a times a times a times a times a. That sounds like a to the 5th. And indeed it is. So when we're multiplying exponentials that have the same base, this is why we get to add the exponents, because we're just multiplying the two strings together. So these are some things you need to keep in mind when doing this. Now, flexibly, if I use both strategies, I'm going to do a new example right here in brown. Right? If I had something like a to the 1/2 minus a to the 5/2, let's say just for the sake of algebra, just because we're looking at algebra tricks really quick, remember that I can factor this. Now, if we look at what this has in common, there's an a to the 1/2 in there, and theoretically I could rewrite that so I could see an a to the 1/2. So I could rewrite this as a to the 1/2, minus, now I could say that there's an a to the 1/2 that's in there, and that means what would I have left over to make the whole a to the 5/2? Well, using my trick from above, the fact that multiplying exponentials with the same base, I add their exponents, I would need 4/2 left. So essentially, if I wanted to factor this, if I wanted to undistribute, pull something out of this that they have in common, something that's multiplied in each, I could rewrite it as a to the 1/2 times the group, because I'm undistributing here, I'm factoring. There's a 1 left there, because that would make the a to the 1/2, minus a to the 4/2, because I've pulled out this a to the 1/2. By the way, 4/2, we all should know what that is. 1 minus b squared. And I think if you look at the trig on this one, that would be nice if it was in trig instead of just algebra. But either way, these algebra tricks, the fact that fractional powers can be rewritten as roots, and the fact that we can multiply exponentials to make new exponentials, and or we can dissect an exponential, kind of pulling it apart to make different ones and be able to factor stuff out. If you look at that, especially with a couple of your questions, that should help you. All right, so that's lesson 1 for the day, and I'm not going to do the problem necessarily related, or actually the problems that are related to this.